linear cost, linear programming. I hope the question or the item was shared already in the group. You should be following it as I read, because we are going to be going through it together as we are here. So in our first item, it's going to come from Jjeb. That was set as item 2. And it reads, a transport company is preparing to transport 700 passengers using 10 drivers and its fleet of buses and coasters. Each bus can carry 70 people at a time, while each coaster can carry 35 people at a time. The manager wants to take the required vehicle for service and fueling to avoid any inconveniences that may arise. This company also owns a truck which the contractor is planning to use to deliver construction material to the site. The truck can carry 3,000 kilograms of cargo or more. The contractor of cement that he should buy to meet his budget. Like I said before, that most these numbers will come from linear programming and simultaneous equation. And when you try to look at the nature of our paragraph 1, where they're talking about the company, that is the transport company, you realize that in that paragraph 1, the numbers or the expressions we are going to generate there is going to give us the simultaneous equation. And we are going to solve those simultaneous equations at least to identify or to know the number of bus and the coaster that should be taken for a repair. So we are given a total of 700 passengers, and all those 700 passengers are using 10 buses, meaning that the 10 buses, it is 10 vehicles. It combines buses and the cost represent the coaster. That is it for that. So that if we are having the combined of 70 people, that will be carried by a bus, and 35 that will be carried by a coaster. I may have my expression here. I'm going to have the expression in terms of A and in terms of B. Then we are going to formulate this, what we are calling the total, or the sum of all. For the first part, they are telling us that it is able to carry the 700 passengers, of which the 700 should be the 70 should come from the bus, and 35 will come from the coaster. But then when you look at the numbers for drivers, the drivers, they are saying they are only 10, meaning that in this line, it is given by a bus and a coaster combined. So I'm going to describe this as a passenger, and then I describe this as the vehicle or the buses. So you can let us say the vehicle. That. So that if I come to my table here, it is going to be very easy for me to form an expression that will be matching with the given total. Like for the first case, I make sure that I have all of this one here. Then we get it to 700. Like this is going to be 7A plus. Then if I get the certified times B, we also get certified B. That will give us a total of 7. So we leave that one there as our first expression that is coming from the numbers of passengers. Then for the buses combined, if I have this one will act as A. That's if I multiply A times 1. Then for the second part will act as a B if I multiply B times 1, giving us a total of 10 drivers. So this one here also will act as the expression. So we can say the expression for driver So this one here is the expression, the passenger. So since the question is asking us to get the number of each type of vehicle that will be worked on, that is the number of vehicles that will be taken for services and fueling. I need to solve these two equations, and then I come up with the value of A and B. The value of A will act as the numbers of buses that will be taken for service, and the value of B will act as the number of coasters that will be taken for service. So it is that. So when I look at equation 2, equation 1, I can first reduce. So what I'm going to do, I'm going to say reducing. You can say reducing equation 1 by, I am going to reduce it by 35. Because 35 is 700 by 35, giving us A, plus 35 divided by 35, giving us B. This is the 7 divided by 35 is 2. Then this one here will act as a B, equals to, this is going to be 20. So since it is a new expression or the new equation, I will also give it a new name, that is the third equation. So you realize that the third equation and the first equation, they are the same. Only that we have reduced the first equation to give us the third equation. Meaning, I will now deal with the equation 2 and equation 3, which is this one here. When you look at in equation 2 and equation 3, you realize that this one here can be easily eliminated. Reason being, when I look at a B in equation 2, it has a coefficient of 1. And a B in equation 1 also has a coefficient of 1. So the only thing I'm going to do here to make elimination easy, I'm going to say equation. Can say equation 2 minus equation 1. So that if I come to my 2A plus B, this one will give us, because we are going to subtract, now I'm going to say it is minus, meaning we can go and say it is 2A minus A, which is the same as the A. B minus B, this one here will go because a B is having a coefficient of 1. And even this one here is having a coefficient of 1. So that one will go. Meaning here I have nothing. Then we come to 20 minus 10, which is the same as 10 here. So if we have got the value of A, the value of A is now representing the buses, meaning that I should also use the value of A we have got to get the value of B. That will be the numbers of coasters. Meaning I will have to use the value of A we have obtained to, I will substitute in any equation. Like if I say here, putting A into equation 1, into equation A being 10, I will put it here. That if this is a 10, what we obtained before, B equals to 10, and then we collect like term because we are looking for the value of B, meaning that we should make B the subject at this moment. So I am going to collect like term, and as we know very well that if anything is a positive, as we are taking becomes a negative, and if the negative as we are taking becomes a positive, meaning that this one here being a positive, it is going to go that side there as a negative. So it will result into B being equals to 10 minus 10, whereby at the end you will find the value of B as a 0. So if the value of B is as a 0, what should we expect to be as our conclusion here? Since they are asking us to get the number of each vehicle type that should be worked on, and we have already seen that in a vehicle type A, that is for a bus, they were 10, and in a vehicle type B, that is for a coaster, they are only 0. Meaning in our conclusion to part A. We are going to say 10 buses. We're going to say 10 buses should be 10 buses should be worked on, or you can say the numbers of vehicles that will be the numbers of vehicles for service and fueling are 10 buses only, because we don't have the numbers of the coasters. So I'm going to make my conclusion here. We're going to say the numbers of vehicles that should be worked on are 10 buses and no coaster. So that was concerning our part A. That was concerning our part A. So as we continue with our scenario, we are going now to paragraph 2. They are saying this company also owns a truck which the contractor is planning to use to deliver the construction materials to the site. The truck can carry 3,000 kilograms of cargo or more. The contractor needs more bags of cement than bags of lime. A bag of cement weighs 50 kg and the cost is 25,000 shillings. And a bag of lime weighs 80 and the cost is 20,000. So they are saying a contractor has a budget of building. So when you are in that paragraph 2, they want us to come up with the constraint that will be under linear programming. And the constraint we are going to develop should be basing on the bags of cement and the bags of lime. And all should also be covered from the weight of each bag in corresponding to the total numbers of bags that should be carried by the truck and the amount each can use for carrying those bags. So what I'm going to do, I am going to develop here a constraint. Each of these constraints, one should represent the bags of cement, another one should represent the bag of lime. So we look at this. Since we are seeing the bags of cement, that is in our part B, I am going to say let X represent the bags of cement and Y represent the bags of lime. Y represents the bags of lime. So now I'm going to generate here my constraint. So I'm going to start with the first part. Constraint for the bags of cement and the bags of lime. If you look at in the first part where the cement than the bags of rice, this one means lime. So it means in our first constraint here, we are looking at the bags of cement being greater than the bags of lime. That is X greater than Y. So this one will be as my first inequality equation. And then in the second part, we are going to generate the constraint for the weight of the bag. So we are going to have the constraint for the bag. The constraint for the bags, we are having the bags of cement being carried at 50. So we are going to have the 50x 300, meaning that we are going to have this one here being given less than or equals to 3. It is given 20. So this is the 20 of y. 20 of y, they are saying the budget. So which means this budget means it is the maximum amount 100 equation. So what I'm going to do, I'm going to arrange this. I'm going to say we are going to get the equation out of inequalities we have performed. Meaning that when you look at in number 1, to remove the inequality sign, we'll only have x equals y. And number 2, we'll have the x equals y. And number 2, we'll have the 50 x plus 80 y. That is that. Then when you look at in number 3, you're going 0x, that is 25,000. And then in the last one, we'll have the x equals to 0. Then we also have the y equals to 0. X equals 0 means the y equals to 0. X equals 0 means the y-axis and y the line. For example, when you look at in the first line, that is x equals y. You realize that in the first line, x equals y, all the values of x and the values of y are the same. If I say that the value of x is 0, meaning that even y should be a 0, because we are saying they are equal. When I said y is a 2, meaning that even x is a 2. So they become equal at all those points. So I am going to start with that, and I'm going to use a very simple formula, that is by use of a table. Using a table, we always use a table just to substitute. It means it is a very simple and very easy formula. So I'm going to start with the line x equals to y. This line x equals to y, I will have my table that will have to be with the, like we said, we are going to get at least a point, meaning that at least means from 1 and above. At least, if I come and say that in my assumption, if I say that let my value of x be 0, since I say that if the value of x is 0, at this point, meaning that even our y is 0, because we say x and y are the same. And if I come, maybe I change, I start with the y this time around, and then I say if my y is equal to 2, meaning that if my y is equal to 2, even my x is going to be equal to 2, because still they becomes the same. Then I will look at now where are the points we have obtained. We start from here. The points we have obtained should be arranged in terms of x and y. Like if I get the first value of x, which is a 0, even my y is a 0. So you have the 0 and the 0. Then if I get the second value of x, which is a 2, meaning that even my y is the same as a 2. So meaning that at this point, it is now what we are going to use when we are going to draw this line. We come to the second line. Our second line is the 50x plus 80y, which is equals to 3,000. I'm going to use the same approach of having my table being form of x and y. If I have that table there, still I'm going to say when my x is 0, we are now going to get the values of y. So you realize that when my x is 0 here, if I come and substitute for x in our expression here, which means we are going to have the 50 times 0, and you know any number which is times 0 remains 0. So at this point, the 50 is eliminated, meaning that we are going to get value of y. That's using the expression 80y 3000. So if I go and divide both sides by 80, that is having 3000 divided by 80. You realize that this is going to give us around 35, going to give us around 37. If I, at the same time, if I make the y as a 0, meaning that if my y is a 0, we are going to substitute for 0 where we are seeing y in our expression here, meaning that this time I'm not going to touch x, but we are going for y. We will come and put this point. We are going to have 80 times 0, which is the given value of y we have obtained, meaning that we are going to only have 50x equals to 3000. Then we also divide by 50 to get the value of x. So the value of x here is going to be given as the 60. So meaning the point we are now going to use at the moment will be 0 for x and 37 for y. And then the next one will be 60 for x and 0 for y. That is concerning the first line and the second line. Now we can wrap up with the third line. Our third line is given as 25,000 x plus 20,000 y equals to 1,500,000. 1,500,000. See, I'm going to say we have x and we have our y at the same point. So I'm going to use the same approach. I will say that if my x is a 0, if my x is a 0, meaning that at that point 0, we will substitute for x, which is a 0. We will end up eliminating the 25,000. So that will remain is 20,000 equals to 20,000 y equals to 1,500,000. So 1,500,000, you realize that the value of y at this point may be around 70, maybe around 75. That is for that case. And for the second case, I will also say when my y is a 0. When our y is a 0, we only have 25x equals to 1 5 divide both sides by 25. So you realize that if I have that, that is 1,500,000 divided by 25,000. We'll have our y as the 60. So meaning that our coordinates there also, we'll collect them as the first one being 0 and 75 for x, and then 60 and 0 for y. Those are the constraints you're going to use. I said before that the line x equals 0 and y equals 0, they represent the two axes of the graph. That is the y-axis and the x-axis. Meaning at this point, we are going to look at how can I represent this on the graph. But before we look at how to represent, we also have to first look at the nature of the lines each constraint will represent. Like the signs we are dealing with here, you realize that we are dealing with the greater than sign. We have the less than or equals to, that can be called the maximum. And we are also having the less than or equals to, that may also be called a maximum. And we always based on only two types of line. That is when I am representing these things into the inequality or into the linear programming. So we are going to look the line for x equals to this one here will be given as a solid line. The solid line can also be called the complete line, and the dotted line can at times be called the broken line. So let us look at how this can be represented graphically. So like I said before, that the line y-axis is being represented by x equals 0, and the line x-axis is being given by y equals 0. That's why you see in my labeling here, you realize that on x-axis I've put y equals 0, and at the y-axis I've put x equals to 0. So we come back to this. We are having our point, and then look at on our point. Each axis. On the x-axis, if I try to look at the bigger value, realize the bigger value on the x-axis is given as the 60. Then on the y-axis, you can see that we are having 75. So to make it easier, someone may go and use a scale of, let us say, a scale of 2 centimeters to represent. If I use a scale of 2 centimeters to represent 10 units on both axis, this one will imply that each 10 small boxes will be represented by 10. So if this is 10, 20, third, fourth, fifth, and the 60. That was the maximum value on the x-axis. I may also put here some negative. Then we also come up here. This is the 10, 20, third, fourth, fifth, sixth, seventh. Maybe I go up to 8. Still, I can add in here some negative values. Then we can plot our lines. The first line is x equals y, whereby x equals y was presented by the points 0, 0, and 2, 2. You know 0, 0 is the origin point. So meaning that if I'm going to plot this, we are going to have 0, 0 at this point. Then we also look at 2, 2. 2, 2, we are looking at 2 being on the x-axis and another 2 being on the y-axis. So this one here may be generated from my estimation here. From your graph there, you're going to be able to draw it very well. But from mine, since I'm not going to use the graph, I am going to estimate. At least if I get from here up to there, we say that there are 10 and there are 10 small boxes, meaning that at this point, each small box represents 1 unit. And if I want 2 units, which means I'm going to count 2 small boxes. So mine, I am assuming that it is here, maybe an here. So this will make me to put my coordinate, my point at that. And then our line, we said before that it's supposed to be a dotted line because of a greater than sign. So yeah, I'm going to have a dotted line. That is that. So I'm going to label this line x equals to y. Then you can line that
80y equals to 3. 0 and 6 0. 0 is for x and 37 is for y, meaning that my x axis is 0. My y axis I will have 37. 37 it is between 30 and 40. From your graph, you're going to count 7 small boxes. That is from 30. That's where the 37 will be. So mine, I am assuming that it is at this, is at that point. Then on the next one, we are looking at 60 and 0. The 60 is for x and the 0 is for y. Meaning, at this point, we don't have the coordinate of x, but we don't have the coordinates of y, but we are having x. I am going to look for where there is 60 at x-axis. That is at this at that point, because we said it's the 0, and this is where y is equal to 0 when we have the coordinate of x. So I am going to join this point also. These points we are going to join them using a solid line, because the constraint or the inequality represented there was given less than or equal sign. So we can join this using a solid line. So this line here, I'm going to label it as this was 50x plus 80y equals to 3,000. That was our line. Then lastly, on the line, we'll have the line that was represented by 25,000x plus 80y equals to 1,500,000. But those lines, we got the coordinates to be 0, 75, and 60, 0. Meaning that at this point,
0 and 75 on y. You realize that 75 is going between 70 and 80. That is a difference of 5 small boxes from 70. And then 60, 0 with the same sum at the same point. That is here. Then I first draw it using a solid line. So we have that. So this is the same as 25,000x plus 20,000 y being given to 1,500,000. So those are our, that is how our graph will have to look before shading. So we are going now to shade. Shading means that we are supposed to get the visible part of the graph. For which the visible part of the graph, we'll have to shade it by first of all testing each and every line we have drawn apart. So for each and every graph we have, I am going to start with the first line. The first line was given by x greater than y. The x greater than y, we are talking about this line. And the easiest way I am going to do this in order to test, say that we are going to look for the points that may not be lying on this line. Like for example, if I come and say I am going to take I will make it easy by taking any point that is just on the line. Like for example, if I take 10 and 0, 10 and 0, meaning that I have taken a point that is direct at the x-axis, that is at this point. So this point, we have taken the value of x and we have taken the value of y. Let us substitute in this. Where we are seeing x, I put 10, and where we are seeing y, we put 10. So you realize that we are going to have the 10 for x being greater than the y, which is the what? Which is the 0. Now, the question comes, is 10 greater than a 0? The answer is yes, because something to be greater than means that that value is bigger than the other. So here we are going to say it is a true. So it being a true means that where we have taken that point, or the side we have taken that point, qualifies to be the region that line. Meaning that in my shading, this side here, we are not going to shade it because this is the true side. We are going to shade the part which is not true. That is the upper side of the line. That is for that line. I am going to take another line that was in 50x. 50x plus 80y. Well, we said this was less than or equals to 300. 3,000, I mean. So this is our line. We are going to take another point which is not going to lie on this line here. Any point that is outside this line. Like if I come and I say maybe I take the point from down, someone may end up going to, let me say, I got to 10, 20, and 10. That is this one and this one here. You realize that 20 and 10 is on this side of the line. If I say taking 20 for x and 10 for y, then you substitute this. Where there's x, I put 20, and where there's y, I put 10. So you have a 50 of 20 plus 80 of 10 being less than or equals to 300. So at this point, when I look at the 50 times 20, you realize that it is given by 1,000. Then this one here is the same as the 800, which is less than or equals to 3,000. Let us try adding this. When I add in this, you realize that this is the same as 1,800 being less than or equals to 3,000. So we take a look at this point and then we make our decision. When you look at 1,800, you realize that it is less than the last part. The last line that is 25,000 plus 20,000 y. This is supposed to be less than or equals to. Supposed to be less than or equals to. So I'm going to have the 25,000 x plus 20,000 y being less than or equals to 1,500,000. This is our line. Where you're seeing my line moving is our line. So in this line, also I'm going to take any point that will not be lying on this line. Like for example, this time round, I want to take the point which is that side. If I take the point which is that side, I may even just come and consider any point. Let me say I have considered the point 30. I'm considering 50 and 30. So if I come and use the 50 for x and 30 for y, substitute, you have the 25,000 of x, which is the 50. We have taken a plus 20,000 of y, which is 30, being less than or equals to 1,500,000. Let us see which side it is going to be. So this side I'm seeing that we are having 1,500,000
850,000, which is less than or equals to 1,500,000. So now the question will also come, that is 1,850,000 less than 1,500,000. You will realize the answer is a no, meaning this side is not true. This one here will act as the follow. And we say that the follow side, we only shade the side where the point was taken from, meaning this time this two part is this side. That. Then I remember we also represented these lines, that is was the y equals 0 as y greater than or equals to 0. Then this one here, they always take this side, and also this one here takes this side. So you realize that in our graph, this is the feasible part, or it is the unshaded part, and it is going to be the one that will be helping us in getting what the question was requiring us to do. So let us move back to the part of the task. In the part of the task, they are telling us that we determine the maximum number of bags of semen that it should buy to meet easy budget. Remember, its budget was for 1.5 million. So I am going to use the constraint that will give us the maximum of 1.5 million. We said before that maximum means that it should stop at that amount. So it means we are going to get something that is going to be the maximum, or the bigger value should be 1.5 million. I'm going to use the constraint for the amount that was represented by 25,000 x plus 20,000 y equals to 1,500,000 shilling. So it is going to be that. I'm going to use the graph. So I am going to, we are now answering part, we are answering still part B. That is our part B, yes. So we are still on the graph. I am going to use using the constraint for amount. I'll take only three. So I am going to use the 25,000 x plus 20,000 y being equals to 1,500,000. 1,500,000. Let me first answer the question someone has given me there. Someone is asking that are we supposed to round off when we are dealing with the coordinates? The answer is yes. You may get something like 37. Plotting this one is easy for you on the graph. That is specifically for someone who may be using, let me say, a graph where a unit is being represented by two small boxes. So you realize that if I have in my graph, let us assume that this is my two small boxes, and then I put here 1. This one here will be acting as 0.5. Then you go to 1. Again, you go to 1.5 and 2. So this person with 37.5 can easily plot for this. But if I don't have that, or if I have, let me say I have 1, it is also okay for someone to plot the 0.5 in the middle if you don't want to round off to that value of 38. Or you can round off to make the 38 so that you put it at exactly the point where it will be quiet. So we come back to our constraint now. In our constraint, we are having our equation here. So in our equation, this equation here was represented by less than or equals to. That's the basic on the inequality. And in our less than or equals to, I am going to look at the points that is in the feasible region. I will use only 3 by side. The point from here, let me say I first use the coordinate of 10 on y, then maybe I also come and look at the coordinate of 40 on x. So if I take 10, if I take 40 for x and 10 for y, have the x which is 40 plus the 20,000 of y which is 10. This value should be 1, should be 15, 150. That is 1,500,000. So we are expressing for that. That is 40 plus 20,000 of 10. So this is 1,200,000, which is still less than this will be less than or equals to 5 that. So we are also solving for that. So this is 1,350,000, which is less than or equals to 1,000,000.
So I want to base on
the expression we have got. The first one is the 1,200,000 after using the values of x equals to 40 and the value of y equals to 10. Then the next one is 1,350,000. That is after using the value of x 50 and the value of y, which is the 5. So when you look at all the two values, you realize that all of them are not exceeding 1.5 million. So I am going to conclude my answer to the one which has given us the value, which is approximate to 1.5. That is the 1,350,000. So implying that if I go back to my item or in the tax where they're saying determine the maximum numbers of bags of lime, the bags of cement that it should do buy to meet easy budget. At this point, the maximum bags of cement is going to be 50 bags because before we presented cement to be x, because that is the value of x that has given us the bigger value of that has given us the bigger amount, or that has tried to be the maximum of the budget. So that was the concerning the Jjeb. I said before that the item was set from the linear programming and simultaneous equation. So our second item